I would like to start by making an introduction with Professor Ahmed Elgammal. It's a great honor to have you today, Professor Ahmed. Professor Ahmed is professor of the Computer Science Department and is the founder and the director of the Art and AI Laboratory, and is part of the Executive Council faculty at the Center of Cognitive Science at Rutgers University. Professor Elgammal he has published more than 180 peer-reviewed papers, book chapters in the field of computer vision and machine learning. He's a senior member of IEEE, and he received several National Science Foundation research grants, including Career Awards in 2006. And Professor Elgammal's work in discovering art history received worldwide attention, including the Emmy Awards, and his work gained a lot of attention in the media, and for example, the HPO Silicon Valley, MIT Technology Review, and many others. And with that, I would, with great pleasure, I would like to you to take the stage away, Professor Elgammal, and the talk will be about art at the age of AI, and it's a very exciting title, and hope that we'll learn a lot about it. Thanks so much, Professor Ahmed, for joining us today.
Thank you very much. Thank you for inviting me, Mohammed, and all the organizing committee. It's a pleasure to be here. Let me start by sharing my screen. Thank you for the nice introduction. Let me start by sharing my screen. All right. I'm going to talk about the topic of the workshop, Art and AI, and a little bit of background about myself. So I'm a computer vision person for a long time, 25 years working in computer vision. And as we know, in computer vision, if you look at an image like that, and the machine can recognize there's a man, there's a woman, there's a fruit, there's a tree, that will be a success. That's what we want to do in computer vision. However, if you look at art, usually it's much deeper than that. There are layers and layers of understanding happens when we look at art, historical context, social context, emotional effect. There are lots of things happen when you look at art, and obviously machines are way beyond. It's really behind in terms of understanding these concepts. Since the ultimate goal of AI research in general is to make machines that has perceptual, cognitive, and intellectual abilities similar to those of human, I really find that analysis of painting involves several challenges, several of these challenging tasks that combine these three abilities. And I believe everybody in the room also agree with me on that. That's why we are here discussing this. And as the previous speaker mentioned, basically, we always hear this question, isn't art as aesthetic judgment subjective and science objective? And that's a very interesting philosophical point that we need to address. And here's my point on it. I'll make my point only through a couple of quotes. Here's a quote from Colin Martindale, who is a psychologist at the University of Maine. He's saying basically, as a scientist, I feel that if everything in the universe is governed by laws, then art history must be as well. So that's totally scientific view of art, and this is in the beginning of his book, The Predictability of Artistic Change. And then another quote from Eric Kandel, the Nobel laureate. Basically, he's saying, by examining the perception of art as an interpretation of sensory experience, scientific analysis can, in principle, describe how the brain perceive and respond to a work of art, and give us insight into how this experience transcends our everyday perception of the world around us. Can any aspect of art, which is creative and subjective experience, be studied objectively? And finally, a quote from an art historian himself, George Kubler, from the book The Shape of Time, remarks on the history of things. He's saying art history could prove to contain unexpected potentiality as a predictive science. So this is basically summarize my views about this. I believe there is a lot of scientific things can be done about art, whether it's analysis of art history, analysis of how we understand art, or as this workshop focus on creating art itself. So I'll try to give you insight about what are the implications of looking at art through the eyes of the machine. So I established the Art and AI lab at Rutgers almost 8 years ago, really to study this problem, how to advance AI by looking at art, but also what can we do in art using AI. And here are some of my collaborators for a long time, Professor Mariam Mazzoni at College of Charleston. She's an art historian. And from the art side, Professor Elizabeth DeMoray from the fine art at Rutgers Camden. And I've been working, I'm blessed to work with many students in the past and currently, including Muhammad, by the way, who's also in the lab. So it's a great journey. This is a student from Rutgers and other places as well. So here are some examples of what we have been doing. I don't have time to go over everything, but we started basically by simple tasks like given an image, can you predict what is the style of that art, what is the genre of that art, who might be the artist who made that art, things like that. And then we moved into more deeper question like, can you build competition models that can help discovering artistic influences? And here you can see example of two artworks, one by French artist Basile from 19th century, and here by Norman Rockwell. And the machine can look at them and really find striking similarity in terms of composition. So you can see three people here, a chair here, an oven here, a big window here. Even the composition of the scene to four quadrant is clearly similar. So here the machine really looked at two pieces of art that nobody have seen them next to each other. They are different time, 70 years apart, different continents, and nobody even thought that these are related. But the machine really can look at millions of artworks and really find these influences in a very interesting ways. We also have been working on understanding creativity, basically. How can we build a model to quantify creativity? Can we, for example, look at the history of art and understand which artworks were more creative and what that means? So there's another topic. Unfortunately, I won't have time to talk about that. How style evolved over time? Why style evolved over time? This is something I'm going to talk about a little bit in more details today. So let's dig into that. But before I dig into that, just one more thing. When we're talking about AI and art, there are extremely two levels where we can look at art, and both of them are very useful, and anything in between is valid. So we can look at art at the macro level, where basically every artwork is just a point in a big space, and what that can tell us about how art progressed and how art history evolved. So that's basically at the macro level. At the very bottom and at the micro level, we can look at the artwork at the stroke level and analyze the stroke level and do things like authentication. So this from a work that we have done where we show that actually you can tell Picasso from Matisse from Chile from drawing from a single stroke at a time. Just looking a single stroke at a time, you can classify that stroke and tell whether it's Matisse or Picasso, which is really phenomenal. Let's now start our journey and look at basically an artwork like that and what language artists use when they talk about art. So basically when artists talk about art, they have certain language they use. They talk about elements of art, things like space, texture, form, shape, color, tone. They talk about principles of art. So they talk about movement, unity, harmony, balance, contrast, things like that. And then they talk about subject matter, brush stroke, the meaning, the historical context. All these are things that covered by artists and art historian when they're talking about art. So if you want to build a machine that really has anything to do with art, really you have to start addressing all these things. And the machine has to understand all these concepts. So we have been working over the years to how can we learn some visual encoding of images of art that help us understand and quantify all these concepts. So in particular interest to many people, I guess, is the topic of style. what is a style? And this is something I want to mention a little bit here. So here is an example of famous painting, a famous subject matter, which is the Last Supper, and depicted in so many different styles. So here you can see Da Vinci famous Last Supper, which is in Milan, and here you can see an earlier version from 15th century, and here you see all other different versions of that by different arts, different age, including Dali's version in 20th century. So that tell us basically something about style, and also tell us something about what we in computer vision and AI in general are doing wrong with the style. You see a lot of style transfer papers, lots and lots of style transfer, hundreds and thousands of style transfer papers. None of them really deal with style in this way. All these papers more or less deal with style in terms of color palettes and some texture. Try to apply that and translate from one image to another. But if you look at style, it's much more complicated than that. The way subjects are depicted, the composition, many other elements are related to style. So that let us really try to understand this problem deeper. What characterizes the sequence and evolution of art style over time, changes over time, and which factor drive changes in styles over time? These are the two main questions that we try to address. Basically, why style change? Why Renaissance came around, and why did artists change their style to Baroque, and why Impressionists happened? So there are many reasons that causes these changes. But how can we characterize these changes also? So these are the questions we're trying to answer by building some computational model that help answer these questions. The very first early things that we have done as a naive, basically AI person going into that area was basically looking at art style classification. So style seemed to be a perfect problem for machine learning. You have Renaissance, Baroque, Impressionism, Cubism styles that sounds like labels. So why can't we just formulate this as a supervised machine learning problem and do style classification? Yes, we can do that. So we have done a lot of work in that, where basically take an image of a painting, try to find some features, low level, middle level, high level feature, capturing these elements of art that I talked about, and pass that to some machine learning classification and classify styles. It's straightforward. And this table show basically work we have done over the years. We're using different vision encoding and different machine learning techniques. And here is a classification result we can getting, which you can compare to random guess. So we went from 4.5%, 4.5 times the random guess to 12 times the random guess. So yes, we can do style classification at the level of maybe a first year art history student, something like that. So, but why that's important? So when you talk to art historian and tell them, okay, the machine can do style classification, they tell you, okay, first, that's not important, because this problem of style classification is not even an important problem. Nobody cares about it in the art history community. And if the machine can do it, so what that tell them? Why that's important? The important issue is really what tell us about the characteristic of styles and what drives style change. Can we tell anything about that? We know that if the machine can classify styles successfully, this means that the machine has learned some internal representation that encodes some features that help to discriminate between styles. So what are these features? However, we also know that machines usually use visual features that are very hard to interpret by humans. So it's very hard to tell from the representation what the machine has done. So we try to really look at what the machine have done and try to understand that within the scope of what art historian do to understand the style problem. And here is basically the main figure in art history when talking about style is basically Heinrich Wölblin, who basically studied the concept of style. So basically, it's studied basically how analysis of subject matter can be the expression of that subject matter in art, which is basically the form and style. And in particular, Wölblin suggested that there are 5 different pairs of comparison we can do to tell the difference between two particular styles, Renaissance and Baroque. So here's a typical Renaissance art, and here's a typical Baroque art. So what is the difference between them? Why this is Renaissance and why this is Baroque? What's the difference between them? So these pair of elements, which basically in machine learning we call them features, basically linear versus interleaves. If you look here at Renaissance, you can see how the contours are very sharp and clear, while in Baroque everything becomes fuzzy and you cannot really see the boundary. It's painterly. In Renaissance, everything is planar, everything in one plane. While here in Baroque, you can see depth. Things are subject are in different layers in the scene. Here in Renaissance, everything is within the canvas. It's closed. While here it's open. Basically, it's like a cropped window from a bigger scene. Here you can see every subject by himself. So that's multiplicity. While here you can see unity. Everything is coherent in one unit. Here, clarity is absolute. Everything has absolute clarity. While here, the clarity is relative, based on depth or based on what the artist want us to focus on, so artists can play with that. So Wolverine suggested that these are the 5 pairs that you can tell the difference between Renaissance and Baroque along these dimensions. Moreover, he suggested that basically these pairs are, you can use them to tell the difference between all styles. All styles basically vary along these 5 dimensions. However, this is art history theory, which what we call in science conjecture. We still have to prove that. So how can we scientifically prove that or validate that? So what we did is basically we used basically several deep learning networks. We trained these deep learning networks to classify styles as we did before. So we give it an image as an input and some style classes at the end. However, the goal again is not just to classify style. The goal is to dig deeper to see what the machine have learned internally. So we start basically pushing the network to learn the same concept with smaller and smaller nodes internally to increase the interpretability of the representation, and start analyzing this representation using different methods, things like principal component analysis, independent component analysis, manifold learning, correlation with time, correlation with Wolverine pairs that I mentioned, different things. So let's try to look at what the machine have learned. So here, what I'm showing is the first 2 principal component or modes of variations of the activations of the network, basically the activation of the last layer of the network before the classification layer. And we found basically that, let me just jump ahead. I don't have that. Okay. We found that around 75% of the variance can be explained by these 2 dimensions. So there are 2 dimensions in the data that explain 75% of the variance of all the images in our dataset. Here we are using a dataset from Western art in particular, spanning the last 500 years. So what that tell you that art evolved in the last 500 years, and this can be explained by 2 variables. What are these 2 variables? Here I'm showing the 2 variables here, and let's try to make sense of this. So the first thing we are doing here is that let's color code these paintings in a sample visualization set, and we color code them based on dates. So this is from 15th century all the way to 20th century. And strikingly, the first thing we notice is that things are clustered very well in this space in terms of time. However, that's very interesting because we never tell the machine anything about time. We only give the machine here the images of the artwork and the style label. So we never tell it the artwork is done in a certain year or certain century. We never tell the machine that Renaissance happened before Baroque or anything temporal at all. The machine basically found that in order to classify styles, it has to arrange art in a certain way in the representation in order to achieve this. And in fact, we find that if you look at the correlation clockwise in this figure, it has a 0.7 percent correlation coefficient with time. So it's highly correlated with time, and also this axis is highly correlated with time. So that's really interesting. And what's also interesting is that This is the same across many different networks we have used. We used AlexNet, VGGNet, ResNet, a variety of configuration, and all of them show the same correlation. So it's not a matter of network, it's something essential in the data. So so why is that? So basically that tells us something very important, which actually Wolverine actually in one of his writings actually explained, or basically hypothesized. Basically, Wolverine said that art history has to evolve, or style change has to evolve in a smooth way. So something has to come after another in a sequential manner in the way style happens. So, for example, if this Renaissance, artists cannot jump from Renaissance all the way to Impressionism. Baroque has to happen first, and then you can find academic art in the 19th century, and all that led to Impressionism, and all that led to post-Impressionism, and all that led to Cubism and abstraction. So things has to move in a smooth way. That's basically his hypothesis, and that's exactly what the machine he confirmed in this representation. What are these two axes? How can we interpret these two axes, like the meaning of these two axes? Everyone can have different interpretation of what they might mean, but what we did is that we correlated them with Wolverine concept that I mentioned. And we find that the first and most important axis in all the networks is basically correlated with the concept of recessional versus planar. So that basically seems to be the most important aspect that have changed over time. And the second most important dimension is always correlated with linear versus ventrally. So these are the real most important concept. And here actually you can get an interpretation of what happened in art history in the last 500 years of Western art. So you can see Renaissance here, where basically art was totally planar and basically linear. And then came Baroque, and things become more ventrally and more recessional in this direction. So more recessional concept of depth started. And then as we go, artists start increasing being ventrally until the ultimate ventrally experience, which is basically Impressionism. Impressionism is everything is fuzzy, you cannot see any contours, everything's just brush strokes, ventrally brush strokes. And this is the most ventrally experience in art history. And then from that came Cézanne and post-Impressionism, which started basically to go planar again, started to flattening the scene again, and started to go back to be planar. And then came abstraction and cubism, and you can start seeing basically things become linear again. So something like Warhol or Rothko or Mondrian is totally linear and totally planar again. So it seemed that basically art history evolved over the last 500 years in a whole cycle in terms of these two variables, going from linear, planar, all the way back to linear and planar again. However, this is not the only interesting thing. As I mentioned, this is consistent in all the network. Here, basically, we can actually validate Wolverine hypothesis about the separation between Renaissance and Baroque. Here, these are the two dimensions that maximally separate Renaissance and Baroque. So in the top here, you can see Renaissance, and top corner here, you can see Renaissance work, and here you can see Baroque works. And basically, if you look at the two axes in this figure, you find that they actually exactly correlates with the 5 concepts that Wolverine mentioned. So Wolverine basically was correct in identifying this concept as a separation between these two art movements. However, also all these concepts that Wolverine suggested are correlated to themselves. So we don't need all of them basically, as have seen here. We only need 2 of them to do the separation between Renaissance and Baroque. However, we also found that Wolverine is not correct in saying that these 5 elements can tell us the difference between all style movements. For example, we find that if you want to tell Impressionism from both of these factors is relevant. The correlation, the axes that separate impressionism from post-impressionism doesn't correlate at all with any of these aspects. Another kind of analysis we have done on this activation of these networks is understanding the manifold of activations. And that can give us also another very nice representation of how art history evolved. So you can see basically Renaissance here, and then things move to Baroque, and then New Classicism coming after that, and then Realism of 19th century, and then Impressionism here. And then after Impressionism, something interesting happened. So basically, post-Impressionism here, you can see basically art moving into two directions. You can see basically Cubism and abstraction in that direction here, where you can see Picasso and Braque and Kandinsky, but also you can see post-impressionism moving into expressionism and connecting more into what happened before in art history. So these are basically the dynamics of what happened in art history as seen by the machine. And that actually leads us to some very interesting observation as well. So we can see here, for example, Impressionism moving to Cubism. If you look at this post-Impressionism era, something very interesting you can notice here. So you can notice here in this connection between Impressionism and 20th centuries abstraction and Cubism, all these artworks here in between is actually artworks by mainly by Cézanne. So you can see some Van Gogh here, but all that is mainly Cézanne. So it seems that Cézanne has been very crucial in transitioning from 19th century to 20th century art. And this is something we see in all, again, in all networks. So here, another very interesting example where here is Impressionism, and you can see here Cézanne forming a bridge into Picasso and Braque, basically Cubism and Malevich and other abstract artists. So that's very interesting connection. And when you look at art history sources, and even if you look at just Wikipedia, here is a very interesting quote. Basically, Cézanne is said to have formed the bridge between 19th century Impressionism and 20th century new line of inquiries, Cubism. Both Matisse and Picasso are said to have remarked Cézanne as the father of us all. That's very interesting because obviously, when an art history book mentions something like that, they mention it in a way not a quantifiable way. But here, the interesting thing is that we can see that this in the data. We can actually almost touch this bridge in the data. We can see it, quantify it, we can measure it, which is really something interesting because now really you can see that art history can be approached really as a scientific discipline more than just a historical discipline. Another interesting part of the analysis is that when you look at this manifold representation, because of the way manifold learning work, it really tries to connect every artwork with the other similar artworks. And basically you can see here several of the Renaissance artwork has been pulled away from the Renaissance crowd into modernity, because probably these are very influential art pieces from Renaissance into modernity. And when you look at this in details, we find that these are mainly artwork by two artists, El Greco and Dürer. So it seems that El Greco has significant influence in expressionism and 20th century art movement because of the way he painted the bodies and the deformation he did in his extreme mannerism style that extremely affected modernity. And again, if you look at a simple source like Wikipedia, you can actually confirm that basically El Greco is regarded as a precursor of both expressionism and Cubism. So that's again something that we can now quantify, you can measure. Dürer also seems to be very influential. However, it's very hard to really understand why Dürer was influential. I think more research has to be done about Dürer, why he is such an influential figure in modern art. Let me now move into from analysis of art to making art using machine, which I think more interesting to the most of the audience in this workshop. So I just want to point out that basically, as many of you know, that using AI in making art is as old as AI itself. And there are two of the pioneers of using AI in making art, like Harold Cohen is the most known for his machine that he works with the machine collaboratively to make art. Another example, Lillian Schwartz, who was one of the computer graphics pioneers. She also had been worked earlier on using AI in making art, and many others as well. And here are some examples, obviously, that you have, things like Google Dream. In the last 10 years, there have a lot of interest in making art using AI, style transfer examples. And I'm going to talk a little bit about creative adversarial network in this context. So, as we know, several deep neural networks have been proposed. It has the ability to generate images, and it has been used to try to make art. And in particular, GANs, when GANs came around, that was something interesting, and several people start really try to use it in making art. I assume many people here know how GAN work, but I explained in 1 minute. So GAN, the way I explain it always is to non-expert is that suppose you have two aliens coming from outer space who know nothing about Earth, and you task them with the task of painting a flower, and use one of them as an artist, another one as a judge. And you give the judge basically images of flowers, and the alien artist who haven't never seen an image of flower try to guess what the flower is. So that alien will start making random images and pass it to the judge. The judge will look at the art, the flowers, and look at what the other alien generated, and will tell him, okay, that's not a flower. And then the alien will try to make other variations, make templates, color palettes, change the color palette, change the composition, try to make something that might work. And after so many iterations, hopefully that artist can make the picture of a flower. So basically, this is, in a nutshell, this is how GAN work for non-experts. If you are an expert in the room, you know exactly what I'm talking about. In this figure, which is the loss function of GAN, the generator that's committed all that you are familiar with. So the question is, can we give GAN images of art and it can generate art? By definition, if you give GAN any set of images, it will try to sample from the same distribution. So it will try to basically generate images that looks like art. It will try to emulate art. And that exactly happened. I mean, if you look at 2017, there are a couple of papers that try to use GANs to generate still lifes and portraits and things like that, and you can get these kind of results. However, at that time, obviously, and almost till now, when you give GAN these images of art, here we give it, for example, a set of portraits that we can get from last 500 years from the wiki art sets. It starts generating portraits like that, something like deformed portraits. And that's the kind of nature of the aesthetics of GANs in the last few years, which is basically this uncanny look that it's very interesting, obviously, for artists because it's surprising and new. However, we have to realize here, actually, the machine is failing in making a correct portrait as expected. And out of that failure come these aesthetics. So this is basically an art of machine failure, not a constructive way of making art. That definitely reminds us of Francis Bacon portraits, the deformed portraits of Francis Bacon. Very important difference is that Francis Bacon has the intention to deform these figures to convey some emotion, while the machine simply fails to generate a valid portraits, and from that failure come the aesthetics. However, what we were interested in, obviously, as you know, I mean, machine learning has advanced a lot. GANs has advanced a lot in the last 5 years, and we have things like style GAN that can have a very good photorealistic images of faces, but mainly because faces are aligned and you can even write and generate images. There are a lot of advances in GANs. However, the real question we tried to answer back in 2017 was, how can you move from just sampling from the same distribution, just being emulative, to push the machine to constructively make something innovative? How to move from being generative to add some element of creativity. And that's why we established what's called creative adversarial networks, which is a variant of GANs that really try to push this creative boundary. So here is the theory behind it in a nutshell. So basically, in art, it's based on a theory from psychology that explains basically how art has progress over time, and that's basically a theory from Professor Colin Martindale that I mentioned his quote in the beginning. So imagine you are an artist and in any age. If you keep doing whatever you are doing, people, because of habituation, start getting bored from that. So imagine in Renaissance, it's amazing art in that time, but after a century doing that, it's becoming boring. So artists have to innovate. Artists themselves get bored. The artists have to innovate and find something new. So imagine you are an artist living in the early 20th century like Picasso. You have seen amazing Impressionism art, and Impressionism have been around for a couple of decades, and it has been the most important thing. And as an artist, as a young artist, definitely that's interesting, but you need to find something new. And here is the role of innovation. So artists has to always innovate to push against habituation. But the other constraint is that if artists innovate too much, that will not be acceptable. Because according to psychological theory, if you innovate too much, you come into the negative hedonic part of the curve, which is basically people dislike what you're doing. And that exactly happened for Picasso. For example, when Picasso painted the Ladies of Avignon that you see here in 1907, people dismissed it. Even the small circle around him dismissed it. They didn't like it. He kept it in his studio for a long time. Even after Cubism became a movement and a famous thing in the 1915 to 1920, still this was not accepted. It was not accepted until later in the 1930s when it was put in the MoMA. And then art historians recognized that this is basically the beginning of Cubism. However, that's basically an example of too much innovation at the time. Basically, because it was pushing too much, and that was rejected. So really, the great art happened in between, when artists push the boundary of innovation to push against habituation, but in what's called least effort. So that's basically the principle we try to implement in Cannes. And we found that basically artists try to innovate or try to push against habituation in many different ways, in trying to do different subject matter within the same style. And that's usually what happens. So what happens is if you are an impressionist artist, you try all different new subject matter within the style of that you establish, which people labeled as impressionism. So you start, but after you try to do all different facades and all different landscapes, I mean, there are limits to what you're going to do within the style, and that's where your artist has to break out of style. So so that's exactly what we focus on doing, which is how can we increase the arousal potential, this is the term used in psychology, in art, mainly by increasing the stylistic ambiguity, to break out of style in order to create something that's new. However, we have to constrain that by avoiding moving too much away to avoid basically getting the negative hedonics, basically the least effort principle. So the agent here, or the machine here, has to explore the creative space by deviating from established style norms and generating a new art. That's basically what the machine is trying to do. So the way we implemented that, so this is the GAN. We give the GAN the art collection labeled with style labels. And here we equip the discriminator with a style classification. The discriminator will only learn what's art and what's not art, what's real and what's fake, but also try to tell what is Renaissance, this is Baroque, this Impressionism. And now we added the style ambiguity as a signal. So now the discriminator, the loss here also will measure how ambiguous is the style of what the machine is generating. So now the generator has a dilemma, because in one hand, it has to generate something that follow the aesthetics, that follow the distribution, because it still have an art and not art part of the loss. But at the same time, it has to generate something that doesn't fit any existing styles. If it starts generating another impressionist art or another cubism art, it gets penalized because of the style ambiguity. And that boosts the generator now to explore the creative space and try to generate something that still follow the distribution, but really innovative. And skipping the details, basically the details of the loss function, you can look at our papers for that. But once you add this style ambiguity, the kind of creation that the machine starts to generate is totally different from what we have seen before. So if you remove out the style ambiguity and just run this, it's going to be a typical GAN, and what you get is something like that. Here the machine again try to just emulate the portraits, emulate the landscapes, the battlefields, and things like that. But once you put this style ambiguity, the machine behavior is changed now. You can see it learned the color composition very well. It learned the rules of composition, but it tried to make something different. It tried to make much constructively creative things. I'm just I don't have a time in front of me, unfortunately. I forgot. So please remind me when you are like 10 minutes ahead of time if I don't want over time. So anyway, we did some quantitative analysis on that. Basically, a Turing test where we mixed up art by this algorithm CAN and some baseline data sets from abstract expressionism. And another data set from Art Basel 2016. We use this basically because Art Basel is the flagship contemporary art fair, which basically is the flagship of creativity, basically. So we want to really show people artworks that they typically see in a contemporary art fair. And here's the interesting things. So just summarize here. So human subjects thought that CAN-generated images were made by an artist 75% of the time, compared to 85% of the time when they shown art from famous abstract exhibitionist collection, which is our baseline. So basically, people are more familiar with this collection. While where they were shown art from the Art Basel collection, only 48% of the time they thought that this art done by the machine. So basically, people confuse art done by Art Basel to be done by a machine, while CAN, they think it is as art made by human. But besides that, also we find that people associated attributes like likeness, novelty, surpriseness, ambiguity, complexity to CAN images at the same level as the other two sets we mentioned. So why style ambiguity work? Because you might argue that basically if these are distribution and these are the established styles, there's a lot of space you can work to generate an artwork that doesn't fit styles and still be innovative. So you can, why can't we, for example, make something between Renaissance and Baroque, and or something between Renaissance and realism? But the answer to that comes from what I showed earlier. If you look at art history and how it evolved over time, that's exactly what happened. So styles are so tightly followed each other. There is no space to innovate between Renaissance and Baroque, or between Baroque and realism, or between realism and impressionism. All this happened in a sequential way that there is no much room to innovate between them. And that's what answer a very interesting question: why can actually, compared to just typical GAN, create more abstract work than it's sometimes create landscapes and sometimes creates portraits, but almost 90% of what you generate is actually abstract, because basically the CAN find that it's easier to innovate in that part of the space here. What happened in the 20th century, and there are lots of room to innovate in that abstract space more than in the figurative space. That's my answer to this question: is why style ambiguity work and why it generates more abstract. Here's some example from many exhibitions that we have in the past 5 years of GAN works at different places all around the world. It has been received very well, and it really initiated a very interesting discussion about the creativity in the machine. And that led me to really think about how to make this accessible to artists, because our goal is not to replace artists, our goal is to empower artists. And so in the last 2 years, I have been focused on building Playform, which is a platform that we established to really make it accessible for artists to use AI in their work. And the reason why we established that, we find first that most available AI came from big corporate like NVIDIA and Facebook and others, while basically art making and artists are not really the goal of this machine. There are other goals for that. Some artists really amazingly use them, but they have to be really technological savvy to understand them. There are a huge barrier for artists. Artists has to really navigate through a lot of AI jargons, like what I'm talking about today, to understand what I'm talking about, and have to navigate through many advances. Artists has to access to GPUs and know how to code, or at least how to run code, which we all know how it's complicated to give up to what's happening. even if you go to a GitHub and search for GAN, and this is actually a slide from a year ago, you can find actually 33,000 sources available for GAN, open source code for GAN. So how as an artist, how you even start? Which GAN you're going to use? So that's why basically we built this platform, and we try to talk about how these AI technology really fit what are doing, not the other way around. So these are typical GAN in the platform, but our GAN in the platform basically we made it such that artists can really train it in as little as 30 images, and they can get results in as little as 1 hour. Because this is also a challenge for artists. Artists cannot collect a data set of 50,000 images or 10,000 images, or even 5,000 images. Most artists want to work with 10 images. And also, one artists will not have the budget to run it in a cloud for 48 hours. Artists want to get results in 1 hour. So that's what we try to optimize. We added several tools here based on what artists have been trying to do, including things like abstracting an artwork or a photo collection, mixing two sets of art. For example, here artist Carla Ganis trying to create a cat cyborg by mixing cats and cyborg and generating lots of intermediate things in between. That's a very, very interesting for artists, the concept of mixing two sets of images. Style transfer is a very important concept. However, we not only work on a single image style transfer, artists would like always to do a bulk style transfer, like defining style by a set of images, not only by a single image. Many interesting concepts here. And here I just want to end this by showing some example of what artists have done, actual artists have done using AI once they get into the tools. None of these artists are experts. None of them have ever coded in their life. Here's artist Devin Garakhanian from LA, who did this mural for Charlie Chaplin, trying to abstract some photos of Charlie Chaplin and creating surreal look on them. Here's an example of artist Marco Santini, who put his photo collection and his own style of art to let the machine learn his style and generate artwork based. It was stylized, and then he printed them, and on top of it, he painted over them as well. So it's you see a mixed media here, combining the AI generation, the art as an input, and then the thing at the end. Here's a very interesting example. Anne Spalter is one of the pioneering digital artists. She's the founder of the digital art in Yale and many other things. She has been doing digital art for the last 25 years. However, when she did use AI in her work, she was very inspired by the outcome, but she didn't like the very small scale that art generated, 256 by 256 or 512 by 512. That's basically nothing. It's like 1 inch by 1 inch. So she actually came back and used her paint and brush and executed that on canvas. And that's very amazing to me to find a digital artist who, for her career doing digital art, now AI pushing them to go back to canvas and use the AI as a sort of inspiration. So basically, some of her paintings that are based on AI generation, and that's her work in an exhibition in Spring Break LA, and later in Spring Break New York. And all this sculpture is also generated based on inspiration from AI in playful. Another example, artist Kenza Najm, again a traditional artist painter, did this as her actual work, and when she fed the machine, the machine gave her these variations of her work. And this basically the way she sees it, as the machine now is like a two new pair of eyes that can look at her artwork and interpret them in a non-human way. And she likes this very much, and that ended up exhibiting at the National Museum of China 2 years ago. Finally, this is an example from artist Carla Ganis from New York, who uses AI to generate lots of texture maps, and even here she's making a virtual environment, a VR environment, actually augmented reality environments, and using AI really as assets to fill up this environment with all sorts of things, texture maps, animations, and all sorts of things, which is amazing. You can go to each of these artists' websites to look at this. And I'm gonna end up basically by analyzing all that. So we had a recent paper, me and Professor Mariana Mazzoni, where we interviewed many of these artists to understand what did they find out about using AI. And here's some of the findings. So artists understand AI as a major impetus to their own creative process in allowing them to generate lots of imagery very quickly and suggesting new paths of manipulation and disruption of data to create images. For them, it's a vital step in leading them to seeing their own artwork differently. Artists describing the relationship as a partnership. So many artists actually use this term partnership, how they talk about AI, believing there is a real value and potential in pursuing that collaborative model. The biggest gain are found in creative inspiration and creative volume. Finally, our relationship to computational systems as human beings is only going to become more critical, and that artists need to understand that relationship, be involved in its developing a literacy and hopefully shaping the relationship. So basically, artists has to be involved to be part of this relation. So thank you. I'll just stop here. I think I went over time. I don't have a clock. Sorry if I went over time. Thank you very much.
Thanks so much, Professor Elgammal, for this inspiring talk. I think we still have like 10 minutes for discussions and questions. Maybe I can start with a question that relates to the shape of the embeddings and the shape of the art history and movement principles shaped by our art heritage. How do you think maybe the next hundreds? I'm not sure that about this, but if we go forward 100 years, how would you think this picture would be different from what we have today? And maybe how we may position AI art in this representation or this picture?
Sure. So definitely, with every advances in technology, artists take notice, and that affects the way making art. And that happened in the 19th century when photography came around. Photography was first rejected. There was also fear of photography will kill artists, but that never happened. We know that there are more artists than ever now than the 19th century. Photography make it possible for everybody to express themselves artistically. You can go to Instagram and see lots of artistically taking photos. Photography itself became an art form accepted in 20th century after a lot of struggle. So the same thing will I totally believe that AI is impacting the art world the same way photography had done that in 19th century. So more and more artists will use AI in their work as going to be a very standard way of making art. And as I've seen in the examples, artists use AI across the spectrum from the very beginning when they're looking for inspiration, from the point of the creating assets for their projects, or as a final outcome. There are a whole spectrum of how AI can be used, and every artist using it differently. If you are creating a painting, if you are creating videos, if you're creating, there are many ways. And I think this workshop will be a very interesting to see what artists and scientists and engineers work when they work together, what kind of things they can do, and there are always interesting things. But I totally believe that when you give the tool to artists, that's where amazing things happen. So we as scientists, our role is just to make science, and at the end, artists are the one making the art, and the machine is just a tool for them.
I think we have time for a few more questions. So if you like from the audience, feel free to raise your hand if you would like to ask a question.
Yeah, we have a question.
Yeah, Christophe, go ahead, please. Yeah.
Okay, I hope you can hear me. It seems so.
Yes,
thank you very much. So, well, there would be a couple of questions, and for me as an artist, there are some that I'm trying to focus on, or trying to put them in words, and most of them, they refer to the question, the style ambiguity feature. That's something very interesting, but it leads to some kind of a question of inventing, even if we're talking about style and art styles. We have seen this very interesting art historian analysis, let's say, something like that, where you have this art history and visual analysis of art history, and has like a space where you can see the art styles over the centuries changing, and like this space I mean, there seem to be already a lot of works in that space. So if we're talking about pushing the boundaries, it seems like the question would be in terms of style, is there still some place that is beyond the boundaries of those styles, you know, or did already these, and we're not only talking about styles because you know, there's also other different things in art, but is there still a place and space for inventing new styles?
Yeah, definitely, that's a very important question. And when you look at that figure I showed, the two-dimensional plot of art history, and see it's closing a circle over the last 500 years, you wonder with this question, like, where are we going to go if you close the circle? And obviously, these are only two dimensions, and there are other dimensions that artists can go to. I think there are big room for changing styles, and we see it every day. I mean, I think right now, if you look at what's happening in contemporary art and design, and if you think about in terms of concept of styles, you can see that artists really work now in so many different styles. So, and I think now with technology, it's much accelerating the way artists come up with styles and move on. So it's not going to be like in the past, where you can easily look at an era and characterize what characterized that style in that era and give it a name or label. That basically is art history and concept, basically. But style, as art historians also say, and as we have shown here, something very fluid. Artists change it all the time for a variety of reasons. While that change will have been slow in the past, and it has been affected by historical events like why Renaissance and the Baroque interaction, for example, what happened in that time, or technology affecting things like Impressionism or the paint tubes or and photography affecting that. So with all these catalysts, style changes, and now also see it with technology, with computer animation, for example, style of artist has changed, and now with AI, that affecting also. So I think with style always will change, and I don't think there's a limited space here. I think the space is too huge, and there are a lot of things to explore. The thing is basically, as human, we are the one who are constraining that change, because we are too attached to what the way things are done, and we only push the boundary in a very little way because of that least effort principle that Martindale explained. That if we push the boundary too much, our style or form will be not accepted by others, and that's why we push back. But I believe the machine doesn't have this constraint, and that's I believe why the machine is very important here, because really the machine work in general without this constraint, or we can set it up to work without this constraint and really explore something totally new. But we still, as a judge, as a human judge, are the one who actually will reject what the machine generating if it doesn't appeal to our taste at this time and age. While what the machine can be generating can be appealing for somebody who live 100 years from now. It's interesting era that we're living in. But my answer to your question is, I think style will always progress, and there are lots of room also for iteration. We have seen also in the history that how style evolve and go in circles. Like some element of style come back, like in Neoclassicism, how they reused the Renaissance and Renaissance, how it used Roman and how Gothic appeared again in other 19th century movement. So some element of style keep repeating and reinvented and reappearing in a new way as well. So and that was actually George Kubler mentioned in his book The Shape of Time, which I mentioned a quote from. We're talking about basically these cycles in art history and breaking out of style, what's called prime objects, forming a new style, and replica mass, how can other artists start copying that new style when it's appealing to artists at the right time and the right moment? So sorry, I kept talking in different direction, but I think you are raising a very important questions, and it's very hard to answer.
Thank you.
Yeah, I guess it's thank you so much as well from my side, and I guess it's time to move on if we can.
Thank you very much.
Thanks, Professor Elgammal, for the inspiring talk.
Thank you.